Alright, so today we are on radical operations day 2. So this is going to be leading up into our solving equations with radicals and rational exponents. So when we are solving with our radical operations, what we're going to do, when we are simplifying using our radical operations, what we're going to do is first simplify our radicals. So I want to simplify this radical. So I would take 24 and factor it out. I get that 24 is 2 to the third times 3. And root 6 cannot simplify because it's 2 times 3. So that gives me root 6 plus the 2 is going to come out. And I'm still left with another 2 on the inside and a 3. Which means I have root 6 plus 2 root 6. And so if I have root 6, that means the coefficient in the front is 1. So I have 1 root 6 plus 2 root 6, which means simplified, this is 3 root 6. So we'll do number 5 as well. Now number 5, we have 3 different ones that we're using, and then just be aware here that we are not adding on the second one, we are subtracting. So I'm going to do the same thing. I'm going to find the prime factors of each of those radicals. So prime factors of 24, this will change to 3 on the outside, 2 cubed times 3. 3 still on the outside. Prime factors of 12, 2 squared times 3. And then 54, we're going to find the prime factors. So we get an all underneath the radical, because there's not a coefficient there, 2 times 3 cubed. So since we're working with square roots, remember anything with a power of 2 or higher is going to come out to the front. So we get 3 times 2 here. So one of those 2's is going to come out. We're still left with another one, and that 3 stayed inside. We're going to get one of those 2's to come out. We'll have none left over, but the 3 stays inside. And here we'll have one of those 3's come out and have a 3 left over. So this is 6 root 6 plus 6 root 3 minus 3 root 6. So we treat the radicals kind of like if this said 6x plus 6y minus 3x. So the root 6 can only combine with another root 6, not with a root 3. So we would have 6 minus 3, which gives me 3 root 6, and then plus 6 root 3. We can't combine them because what's underneath the radical is different. And that would be my final answer. Now on number 10, we see that we are using cube roots, not square roots anymore. But the process is still going to be the same. So we want to find the prime factors of each. So this is 2 and 3. There's a cube root. Let me zoom in. Oops. So we have negative 2 cube root of 2 times 3 minus cube root of, find those prime factors. So if you have your calculator at home, you're using menu number factor. We get 2 cubed times 5 plus, has a 2 on the outside, cube root of, and then negative 5. So now when we're working with our cube roots, remember that we're going to be taking out any groups of 3 that we have. So that means a power of 3 or greater. So on this first one, nothing can come out because they both have a power of 1, so we'll just keep them in there. On the second one, the 2 can come out. Since it has a power of 3, none of them will be left inside. But we still have that 5 inside. And then whenever we have the cube root of a negative number, we take the negative out. So that's negative 2 cube root of 5. So just like in the other one, we could say that this is negative 2x minus 2y minus 2y. So I can only combine the ones that are alike. So I have negative 2 minus 2 for the cube root of 5, which gives me negative 4 cube root of 5. And since the first one had a cube root of 6, we cannot combine them, so it just stays negative 2 cube root of 6, and then minus 4 cube root of 5. Now on the next page, we're doing 13 and 15. On 13, we have a foiling problem, so make sure you know where your terms are. So there's the first 2 terms, and then here's a term, and here's a term. So sometimes it is hard to see where your terms are, so we'll take the 3 and multiply by both of those. So 3 times negative 4 is negative 12, that'll be lower. And then 3 times root 3 is 3 root 3. Same thing with the 2 root 3, multiply by both terms. So 2 times negative 4 is negative 8 root 3. Again, we treat these roots like variables, so if this were 2x times negative 4, we know that we would take those coefficients and multiply them and get negative 8x. So in the same way, we would get negative 8 root 3. 2 on the outside will stay the same. Then on the inside, we have root 3 times root 3, which would be root 9. So now we're going to combine them like we were on the first page. Here, though, square root of 9 is 3, so that's 2 times 3. So we have negative 12 plus 3 root 3 minus 8 root 3 plus 2 times 3, which is 6. So negative 12 plus 6 gives me negative 6, and then 3 root 3 minus 8 root 3 is negative 5 root 3. And since they don't both have the same radical in them, we stop there. We can't combine them. Now on number 15, it says that we're squaring this. So remember, when we square something, we're taking it and multiplying by itself. So we have root 2 times root 2, which we know when we square a radical, then we are going to take out the radical and just leave the number that's underneath. If you don't like doing that, we could say that we multiply 2 and 2 and get root 4, which the square root of 4 is 2. And then we've got a positive 3 times root 2, then positive 3 times root 2, and 3 times 3. Square root of 4 is 2. 2 plus 3 root 2 plus 3 root 2 plus 9. And we get 11 plus 6 root 2. So I've worked 5 of them, and then you do have 15 of them to do. You do need to get some good practice in with these just so we can be ready for solving using these operations. Make sure that you turn these in on Canvas once you are done.